We move to next topic, buffer overflow. This is often a vulnerability where more data is written into a memory buffer that it can actually hold. The basic idea is simple. When that extra data goes beyond the buffer limit, it can overwrite nearby memory and affect how the program works. The buffer flow can cause different problems such as changing program execution, crashing the system, or potentially allowing malicious code to run. The consequences can be serious. We may see system crashes, loss of access control, arbitrary code execution, or exposure of information stored in memory. There are two types of buffer flow, stack based and hyper buffer flow. So, in stack based buffer flow, too much data is written into a fixed size buffer allocated to programs called stack. This can overwrite nearby stack information. An attacker may try to take advantage of this by changing local variables, manipulating the return address, or affecting function pointers. This slide continues the stack-based buffer flow concept and shows how memory can be affected when the buffer limit is exceeded. To overcome these exploits, programmers should avoid unsafe functions such as getS, strcpy, string concatenation, and spring printf, and should always check the size of input data. This PPT also mentions modern compiler and runtime protection. These security measures can help reduce the chance of successful buffer flow exploitation. Another technique Another technique mentioned here is the NOP shield, which is associated with exploiting stack-based buffer overflows. So next is heap buffer overflow. So now we move to heap over buffer overflow. This heap is the memory area used for dynamic allocation, such as memory allocated using malloc or new. So a heap buffer overflow happens when a programmer writes more data into dynamically allocated buffer that it can hold. This can corrupt nearby heap memory. This type of vulnerability occurs when data is copied into buffer without checking whether the destination has enough space. Finally, then to minimize buffer flow attack, the PPT slide highlights secure coding practice, avoiding unsafe functions, disabling stack executions where appropriate, using compiler tools, and applying runtime checks. This the main takeaway is the careful memory management and secure programming practices are very important. Thank you.